Zircon is a mineral belonging to the group of nesosilicates. Its chemical name is zirconium silicate and its corresponding chemical formula is ZrCO4. A common empirical formula showing some of the range of substitution in zircon is CO4, 1 X, OH, 4 Y. Zircon forms in silicate melts with large proportions of high field strength incompatible elements. For example, hafnium is almost always present in quantities ranging from 1 to 4%. The crystal structure of zircon is tetragonal crystal system. The natural color of zircon varies between colorless, yellow-golden, red, brown, blue, and green. Colorless specimens that show gem quality are a popular substitute for diamond and are also known as Matura diamond. The name derives from the Persian zargun, meaning golden-colored. This word is corrupted into jargoon, a term applied to light-colored zircons. The English word zircon is derived from zircon, which is the German adaptation of this word. Red zircon is called hyacinth, from the flower hyacinthus, whose name is of ancient Greek origin. Properties. Zircon is ubiquitous in the crust of Earth. It occurs in igneous rocks, in metamorphic rocks and in sedimentary rocks. Large zircon crystals are rare. Their average size in granite rocks is about 0.1 0.3 but they can also grow to sizes of several centimeters, especially in pegmatites. Because of their uranium and thorium content, some zircons undergo metamictization. Connected to internal radiation damage, these processes partially disrupt the crystal structure and partly explain the highly variable properties of zircon. As zircon becomes more and more modified by internal radiation damage, the density decreases, the crystal structure is compromised, and the color changes. Zircon occurs in many colors, including red, pink, brown, yellow, hazel, or black. It can also be colorless. The color of zircons can sometimes be changed by heat treatment. Depending on the amount of heat applied, colorless, blue, or golden yellow zircons can be made. In geological settings, the development of pink, red, and purple zircon occurs after hundreds of millions of years, if the crystal has sufficient trace elements to produce color centers. Color in this red or pink series is annealed in geological conditions above the temperature about 350 degrees°C. Applications. Zircon is mainly consumed as an opacifier, and has been known to be used in the decorative ceramics industry. It is also the principal precursor not only to metallic zirconium, although this application is small, but also to all compounds of zirconium including zirconium dioxide, one of the most refractory materials known. Occurrence. Zircon is a common accessory to trace mineral constituent of most granite and felsic igneous rocks. Due to its hardness, durability and chemical inertness, zircon persists in sedimentary deposits and is a common constituent of most sands. Zircon is rare within mafic rocks and very rare within ultramafic rocks aside from a group of ultrapotassic intrusive rocks such as kimberlites, carbonatites, and lamprophire, where zircon can occasionally be found as a trace mineral owing to the unusual magmagenesis of these rocks. Zircon forms economic concentrations within heavy mineral sands or deposits, within certain pegmatites, and within some rare alkaline volcanic rocks, for example the Toongi trachyte, Dubbo, New South Wales, Australia in association with the zirconium hafnium minerals adellite and armstrongite. Australia leads the world in zircon mining, producing 37% of the world total and accounting for 40% of world EDR for the mineral. Radiometric dating. Zircon has played an important role during the evolution of radiometric dating. Zircons contain trace amounts of uranium and thorium and can be dated using several modern analytical techniques. Because zircons can survive geologic processes like erosion, transport, even high-grade metamorphism, they contain a rich and varied record of geological processes. Currently, zircons are typically dated by uranium lead, fission track, and U+THE techniques. Zircons from Jack Hills in the Naria gneiss terrain, Yilgarn Craton, Western Australia, have yielded UPB ages up to 4.404 billion years, interpreted to be the age of crystallization, making them the oldest mineral so far dated on Earth. In addition, the oxygen isotopic compositions of some of these zircons have been interpreted to indicate that more than 4.4 billion years ago there was already water on the surface of the Earth. This interpretation is supported by additional trace element data, but is also the subject of debate. Gallery. Similar minerals, hafnium, xenotime, bar copyright hyrite, eavinatolite Bo4, thorite, and cavinate all share the same crystal structure as zircon. See also. References. External links, Geochemistry of Old Zircons, Mineral Galleries, GIA Gem Encyclopedia, Zircon online articles and information on zircon history, law, and research. Further reading.